Partial fractions allows you to take an algebraic fraction and split that up into multiple algebraic fractions. So here's what I mean by that. Let's say you have something like this, and underneath, let's say you have two brackets, something like that. What partial fractions allows you to do is split this into two separate algebraic fractions. The first algebraic fraction on the right hand side will have a constant as the numerator, and I'm going to use capital A, and then as the denominator it's going to have the first bracket, so x plus 2. The next fraction will have another constant, I'm going to use capital B, and then it's going to have the second bracket, x minus 1, as its denominator. If, let's say, I have a third bracket, then I'm going to have another constant with that third bracket as the denominator of that third constant. That's the whole point of partial fractions. It comes up later on when you're doing integration, because something like this you can't integrate. You need to separate it into three different fractions, and then you can go on to integrating it. That's where it comes in handy. Now, the way we do partial fractions will be twofold, or shall I say there's two methods. The first method is by substitution. The second method is by equating the coefficients. I'm going to take you through both. Let's start off with substitution. So what we're going to do is we're going to take our fraction, and then we're going to write the equivalent on the right hand side. And notice that I'm using 3 lines as my equals, because it's going to be applicable to all values of x. So we have a constant, capital A, and then the denominator is the first bracket, like this. And then another constant, capital B, with the second bracket as the denominator, like that. Cool. Now I want to combine the fractions on the right hand side. So I can have A bracket x plus 1 plus B bracket x minus 3 all over x minus 3 x plus 1. And on the left hand side I have the same thing. I haven't done anything to that yet. Like this. Now, because both the left and right hand side have the same denominator, I can get rid of the denominator entirely. So 6x minus 2 is equal to A bracket x plus 1 plus B bracket x minus 3. Okay, what I can do from here is have substitutes. Suppose I single out that bracket. Let's say if I make that bracket equal to 0, my x value will be minus 1. That will be my first substitute. So let's try it. 6 times minus 1 minus 2 equals A times minus 1 plus 1 plus B times minus 1 minus 3. 6 times minus 1 is minus 6, then minus 2, so minus 8, equals minus 1 plus 1 is 0. So that eliminates that a entirely. And I'm left with minus 4b on the right hand side, which means b equals 2. I've worked out one constant. If I single out that bracket, x minus 3 equals 0, so that means x equals 3. Let's substitute that. 6 times 3 minus 2 equals a times 3 plus 1 plus b times 3 minus 3. Okay, so this will give us 16 equals 4a, which means a equals 4. And there we go. That is constant number 2. So now I can rewrite this partial fraction. If I copy it over and move it down, I can rewrite it. But instead of a and b, I can have the values 4 and 2. And that is your answer. That's how you do it by substitution. Now let's do it by the second method, which was equating coefficients. The first steps of the equating coefficients method is exactly the same. So up until this point, regardless of whether you're doing substitution or equating coefficients, that's the same. The difference is what you do after that. So let me copy that over and I will do it down here. And let's get rid of this line. Okay, here's what we're going to do. We're going to expand the brackets on the right hand side. 6x minus 2 equals ax plus a plus bx minus 3b. From this point, any unknowns, and by unknowns I'm referring to the x in particular, I'm going to equate the coefficients of x. The coefficients of x are 6, a, and b. So that means 6 equals a plus b. And then the other coefficients, let's just stick to x's and then non-x's. So minus 2, a, and minus 3b. Like this. What I've now got is a simultaneous equation. And now, from here, it's just a matter of solving. If I do 1 minus 2, I get 8 equals 4b, so that means b equals 2. And when you substitute b equals 2, you get a equals 4. Regardless of which method you choose, you will get the same answer. So let's say you do it once and you're not sure if you got it right. Do it the other way and see if you get the same answer. If you do, chances are you're probably correct. Is there a right way of doing it? As in, how should I word this? In some cases, only one method works. In other cases, both work. It's up to you to determine which method you're going to use. That just comes with practice though. Initially, I would suggest trying both just to, get into the swing of things and to practice it. It's going to be the same thing pretty much every time. But yeah, you in some cases, you are only going to be able to use one. But that's partial fractions. So what I've done is I've put this question 6. I want you to give that a shot for me, please. Okay, so let's write our fraction as given in the question. And now let's have our separate fractions with the constants. So first is constant A with bracket number 1. Second is constant B with bracket number 2. Third is constant C with bracket number 3. Okay, now we have to combine all the fractions on the right hand side. So they should all be over x plus 1, x minus 2, x plus 5. So we're going to get A bracket x minus 2, x plus 5, plus B bracket x plus 1, x plus 5, C x plus 1, x minus 2. And then this remains the same. Now, because both the left and right hand side have the same denominators, we can make the numerators equal. Like that. From this point, I personally would go with the substitution method because it's going to be the easiest one to do. You're going to have 3 substitutions. The first substitution is x equals 2. The next one is x equals minus 5. The last one is x equals minus 1. In any order, doesn't really matter. Let's go with x equals 2. When we sub in x equals 2, we get 8 minus 24 minus 26 equals 0 plus b times 3 times 7 plus 0. So we get minus 42 equals 21b, so b equals minus 2. Okay, so you sub in x equals 2 on this side and each term on the right hand side, and you're just going to make them equal. So when you do that with minus 5, you get 50 plus 60 minus 26 equals 0 plus 0 plus c times minus 4 times minus 7, which means 84 equals 28c, c equals 3. That's another constant done. The last one, you substitute x equals minus 1, you get 2 plus 12 minus 26 equals a times minus 3 times 4 plus 0 plus 0, which gives you minus 12 equals minus 12a, so a equals 1. That's your last constant. So that means you take your partial fractions and you can now rewrite this as 1 minus 2, 3. There you go. That is your final answer. Okay, hopefully that went well. One more I want you to try. Question 7, please. Okay, step 1 is factorize that denominator. When you factorize, you get 5x plus 4, 2x minus 1. This is going to be equal to a over 5x plus 4 plus b over 2x minus 1. Now we can combine the fractions on the right hand side. A times 2x minus 1 plus b times 5x plus 4 all over 5x plus 4 and 2x minus 1. Because the denominators are the same, you can equate the numerators. Like this. And now you can have two substitutes. X equals a half and x equals minus 4 over 5. When you substitute those in, when x equals a half, you end up with 13 over 5 equals minus 13 over 5a. So a is minus 1. And when you have x equals, that is for this one. When x equals a half, you get 13 equals 13 over 2b. So b equals 2. So your partial fraction will look something like this. Minus 1 plus 2, like that. And there you go. That is how you do partial fractions.